Hi, I'm Ben Stevenson from JourneyToTheCloud.com here for another episode of Cloud Corner. Joining me today is Nick Phelps, Solutions Architect, and Randy Weiss, Director of Solutions Architecture, both from Green Pages Technology Solutions. How you guys doing today?
Good.
Great.
Thanks for having us.
Yes, fantastic. So today we're going to talk about clustered data centers. So I understand that people are getting away from active-passive data centers and are moving more towards active-active models. So if you guys could just give us some background about what exactly this means, that'd be great.
Well, active data centers basically is implying that you're able to use two different locations with IT equipment in them, both at the same time. There's a lot of reasons why this is gaining in popularity. One of them is that disaster recovery, high availability are concerns of a lot of organizations since they're so reliant upon the IT infrastructure that supports their line of business. So people don't want to buy equipment to fill two data centers and then not use one of them. And conversely, they also don't want to kind of go cheap on the second data center so that when they have to use it in the event of a disaster, that it doesn't run well.
Yeah, I think one of the other challenges has always been too is that actually testing failover and failback, right? You have this active data center and a passive data center. It's ready to go. You maybe test it once a year. How valid of a recovery point really is that to an enterprise who's going to depend on that? And I think one of the challenges, what's kind of forced people into that corner has been technology constraints around not being able to have two things survive in the same, two places at once. So we're going to talk about some of the technologies that are enabling people to kind of get around those challenges and realize that active-active model.
Yeah, we've really reached kind of a watershed moment where the technologies that used to be too complex and too expensive are now within reach of a lot of IT organizations. So that when the hurricane does come, you are able to, with a fair degree of confidence now, know that your business will continue to run at the other data center.
Great. And how exactly are companies moving towards this model?
Well, there's a lot of things that have come about to do this. One of the big ones is networking.
Sure.
You want to talk about that?
Sure. So traditionally, some of the challenges, obviously, to have data in two places at once has always been a compute challenge, a storage challenge, and then how are you going to tie it all together with this network, this backbone? And when it's a geographically dispersed environment, you have somewhere maybe halfway across the country, it's always been a latency issue, a connectivity issue.
Yeah, that speed of light thing.
Right, exactly. And then the whole complexity part of it, right? Like you mentioned before, typically the connectivity between these data centers and these sites have always been this layer 3 IP-based type connectivity where if you want to do something where you have a VMware cluster that survives in two areas at once, for example, like what we're going to talk about in a minute, the challenge has always been that it needs to be inside the same physical bounds. It's always thought of as the same building, the same VLAN, the same logical network, and that's never been possible whenever it's separated by this layer 3 boundary. Right. So some of the things that are overcoming that, I think, are the advent of layer 2 WANs between these data centers. Obviously, if you have one carrier providing both sites, typically now they provide you low latency, high bandwidth, layer 2 based connectivity that really do allow you to take that logical network and kind of span it between these two locations, whereas before you couldn't really do that.
Right, and that layer 2 really just means is you're not routing. You're not going from one network to another network like we're used to. Right. It's all basically as if it was all on the same network in the same
switch in the same building. Yeah, exactly. And so now, of course, there's other technologies like you kind of alluded to a minute ago that even if you do have those constraints of layer 3 networking, you're now able to encapsulate that layer 2 environment across those sites via some new technologies from Cisco and HP, and they're kind of coming out with some new things that allow you to get around those in a low latency manner that allows you to kind of federate those data centers into one logical unit. And then on the compute and the storage side, this has always been an even bigger challenge than the networking portion of it. Yeah. There's some things you can kind of talk to that kind of allow you to get around those challenges too, I think.
Right, so because we're so heavily virtualized now in many data centers, and even applications that aren't virtualized, when you have groups of servers and you have all your applications running on these groups of servers, and you want to take part of your cluster and move it down the road, you are constrained still, again, by that speed of light thing, where you can only have a latency of 5, 6, 7, 8 milliseconds. And that's a very quick amount of time. That's as if it's local. So how do you, what's the implication here is that if you don't have that kind of direct connection between the two parts of your cluster, it's going to fail. Now, when you design these things, there's all kinds of design rules around how many of your cluster hosts can fail, how many of your application hosts can fail. What's going to happen to the application? Will it come up automatically? Do you need to manually intervene? And so VMware's vSphere 5 has overcome a lot of these limitations. You can have very large clusters now that you can actually split into two. There's still a lot of consulting and design work that have to go into it because the resources available at one site have to support the mission critical applications that are now running at the other site, or maybe even distributed between the two. So that kind of gets into a kind of a more higher level discussion we have time here for now. Storage is the other part, and that has also been very tricky because most of the applications that businesses rely on are very sensitive to delays, to the latency we keep talking about.
Sure.
So how do you write data to two locations so that if the application using the data here and you have a failure of some sort, or you just simply want to load balance, how is that same application going to access that data, and will it be at the same point in time? Is it synchronous, in other words? So these technologies all have to kind of come together. The storage has to be able to write to two locations at once, active-active, synchronously. Your computing cluster has to be able to run in two locations and still be able to talk and know that it's still alive. And then the networking technology that enables it has come a long, long way. And some of the major partners that we work with have enabled this through a variety of different specialized technologies.
Sure.
Fantastic. Now, is this something that is happening right now, or is this a couple years down the line? And if it's happening right now, where is it headed?
Some parts of this are happening right now. It's not widespread in the storage world. There's only a few major vendors that are allowing this synchronous active-active writing. In the compute world, VMware is continually working on improving high availability and the dynamic resource scheduling that allows the environment to dynamically move computing resources to where the underlying resources can support it. In other words, CPU, RAM, network connectivity.
Sure, yeah, and it's kind of funny, you look at the model of how all these things kind of go together. You look at compute, storage, networking, and you just asked if this is kind of happening now or if this is kind of forward-thinking stuff. And you look at, so that's the logical order that you think about these things being important. But then you look at what enables development of these things, it's kind of backwards. VMware or EMC and NetApp, they can't focus on the storage and compute portion of this whole ball of wax until the underlying infrastructure is there to make it possible. Right? You don't want to design vaporware that can't actually be put into real-world use.
Right. So until the networking was there,
it
wasn't going to happen.
Right. And then you look at major providers, data center providers. They're starting to allow for these 100 meg, gigabit, and faster, even dark fiber connections between these data centers. Ultra low latency, sub 5 millisecond, halfway across the country type stuff. And then, of course, you see HP and Cisco kind of being the thought leaders in the industry in that portion of it to get around if there isn't those technologies. So if there isn't layer 2 connectivity that's low latency and there's not dark fiber between data centers, how are you still going to achieve this model? Well, there's things like OTV, and there's things like Trill, and there's things like Flex Fabric Interconnect, from HP that are right, exactly. They're kind of getting around some of these challenges and really starting to say, hey, you know what? These technologies are real. They're here. VMware and these other storage vendors are wanting to utilize this stuff. We need to make sure that the landscape is transparent, whether they have the layer 2, whether they have layer 3, whatever they have between these sites. So long as it's low latency, we're going to make it work from an infrastructure standpoint. And that's now tied back all the way down into the virtualization and networking layer, down into VMware, all the way to the data center core, and then all the way to the aggregation edge that's connecting and federating these data center sites. So it really is becoming a reality that's kind of spawned by the underlying technologies becoming more and more available, more and more prevalent, and further out of beta and more of a production technology.
And all of this comes down to virtualization. And virtualization means, in essence, that you're masking complexity and you're adding features. So in a network, in a data center network now in one location, your chassis, your big giant switch can now be distributed. You can have virtual line cards that support many of the functions that used to be in this enterprise class piece of hardware called a director chassis. Same thing with the storage. If it doesn't virtualize to the extent that you can transparently manage the size of the data storage and where it gets written, without having a PhD in computer science, it's not going to work. And finally, computing resources. Maybe some of the higher end applications could have done this for a while, like Oracle RAC.
Sure.
But when you take and you put all of your serving infrastructure into a hypervisor like VMware, then you would now have to think to yourself, can I take that SQL database? Can I take that Exchange data store? Can I transparently move these things? Can I, if I'm using up all my resources here, can I just say, you know what, I want it over there? And the end users don't know the difference. So we're masking some of the complexity with this technology, and we're adding features that weren't available before.
Awesome. Well, this has been some really good information. Hopefully everyone watching this found this useful. You can find both these guys blogging on journeytothecloud.com. Nick and Randy both have got posts up there, and both I'm sure will be sending in many more in the future. So thanks again for joining us, and thanks you guys for giving us the information.
Thank you.
Thank you.
Great.